All right, so I think this is recording. Let's take a look at problem number 5. We have a polynomial function of degree 4. That's the largest exponent that I see, and it's in standard form 4, 3, 2, 1, and the constant term. The leading coefficient, the number in front of x to the fourth, is a 1, and that's a positive number. And the 4 was an even. So that tells us that the end behavior of the graph, that when you plug in extreme values of x, that when you're far to the right for very large numbers, it's going to be positive, and for very small numbers, negative numbers are very small, the output of the function is going to increase. So there's our end behavior, which is described in choice 1. The y-intercept, when we let x be 0, is 2. It has coordinates 0, 2 on the y-axis. We will, when I return, we'll find how to generate a list of possible x-intercepts. There may not be any in this list, but if this graph does cross the x-axis, and it does cross it at a rational number, it'll be in this list. So we're looking for zeros, so whether we use synthetic division or plug it in, let's just go ahead and plug it in. We'll have 1 plus 1 minus 3 minus 1 plus 2. And that happens to be 0. So we got lucky and we found it right away. We won't always be so lucky. So let's go ahead and do synthetic division on this, because it's the synthetic division, that result, that helps us to factor it. So 1, 1, negative 3, negative 1, and 2. And we get a 0. Now this is still an x to the third. We can factor it by grouping, but let's go ahead and continue. It could be, we've seen before, that sometimes you have a multiplicity bigger than 1. So rather than this 1x cubed plus 2x squared minus x minus 2, I'm just going to call that r of x. So let's see if 1 by chance is a repeated root. If I would have 1 plus 2 minus 1 minus 2, and it is. So if we do synthetic division again, with a 1, so now we have a quadratic. Now we will be able to factor that with our x method. So we've got p of x is equal to 2 factors of x minus 1, and then we've got x squared plus 3x plus 2. Now sometimes this won't factor. Sometimes we'll have to use a quadratic formula, and even with a quadratic formula, sometimes there won't be any real solutions to that. But this time we can factor it. I can see it. This factors to x plus 1 times x plus 2. All right, so I'm going to erase this over here for room for my table. Table is just a nice organized way to present our information. So we have a 0 at 1 that has a multiplicity of 2, and that means that it's doing a touch and turn on the x-axis. We have a 0 at negative 1 with a multiplicity of 1. That means it's doing a cross. And we have a 0 at negative 2 with a multiplicity of 1. And that means it's crossing the x-axis at x equals negative 2. All right, so I hope that helps, and I will talk to you later. Bye.